Hi, this is Homework Helpers for the third quarter final. I'm looking at Station 2, Bonding and Intermolecular Forces. So here are some examples of dot diagrams. You must know all of these at a minimum. The one you need to remember here is carbon dioxide has 2 double bonds. Remember, nitrogen has a triple bond. Oxygen has a double bond, and those are some examples. Okay, so I'm going to explain whether the molecule is polar or nonpolar. All right, if it is polar, that means I have an asymmetrical molecule. So asymmetrical polar. If it is symmetrical, then it's nonpolar. So this guy here is asymmetrical, so it is a polar molecule. If I look at this guy here, carbon dioxide, that's symmetrical, so that ends up being a nonpolar molecule. If I look at CH4, that ends up being tetrahedral. That's also going to be a nonpolar molecule because it's symmetrical. And this guy here, it has that lone pair of electrons. This is going to end up being a pyramid. And so that's going to end up being asymmetrical, so ends up being a polar molecule. Here it says, explain polar and nonpolar molecules in terms of charge distribution. Here's the key here. Polar molecules have an uneven charge distribution. So I'm going to use the word that they asked me to use. What they write in terms of, they want you to use this word. Make sure it goes in your answer. On the other hand, nonpolar molecules have an even or equal distribution of charge. Okay, so I'm using the term charge distribution. The difference here is that polar is an uneven or unequal charge distribution. Nonpolar is an even or equal charge distribution. Next, I'm going to draw a water molecule. Remember, water is H2O, so there's an oxygen and 2 hydrogens. All right, oxygen has 6 valence electrons, so I'm going to draw them in. Hydrogen has 1 valence electron, so it's going to get shared like that. If I were to draw the dash diagram, it would look like that. Now, I'm drawing it this way because this is a bent molecule, and it's asymmetrical, so it's polar. So if I look at this distribution here, oxygen has all the electrons, so that's going to be the negative side of my molecule, and hydrogen is going to be the positive side of the molecule. Okay? Now, water molecules are held together by a strong intermolecular force called hydrogen bonding. Hydrogen bonding happens when you have a molecule of hydrogen bonded with either fluorine, oxygen, or nitrogen. So you only have 3 choices: HF, water, H2O, and ammonia, NH3. They all exhibit hydrogen bonding. And that's a very strong intermolecular force. So that affects a lot of the properties that water has. Capillary action, drawing water up a straw, surface tension, bugs being able to walk across the water. These are all properties of water that exist because water is bent. Okay? And water molecules are held together by hydrogen bonds. Okay? If I draw my water molecule like a Mickey Mouse, okay, hydrogens and oxygen on the bottom, the mouth is going to be the negative end, and the hydrogens are going to be the positive end. So here, if I'm drawing several water molecules that are oriented negative to positive, so now my next water molecule, I'm going to draw like that. So my positives are attracted to my negative. And then I'm going to go over here. I can do this with a dash diagram also. So here's another water molecule, maybe like that. The negative end of one is attracted to the positive end of the other. That dotted line is my hydrogen bond. Okay, that's why the boiling point of water is unnaturally high. And that's important. That's why water can exist as 3 different phases on Earth at the same time. Okay, so this is a little water and intermolecular force review.